This is a video overview of the VCFR, the voltage controlled filter resonator, which is this two-pole, highly resonant two-pole state variable filter for the hale modular system. So this output block at the top here, we got high pass, band pass, low pass, and all pass outputs with notch response in the center. And if I trigger this really quick, we'll get our LEDs going. There's an activity LED per outer output, and the outputs have been arranged on these outside four outputs in order of their quadrature relationships to each other, so they go round and round. When you're generating low sub-audio CV with this, it's really helpful because you can see the relationship between the different outputs. And if you've got a quad system and you want to get things swirling around the room, really easy to do, but mostly it just looks pretty. At the bottom here, we've got our manual frequency and Q controls, and then we have voltage control inputs for frequency and Q with attenuverters. There's a tuned and temperature compensated 1 volt per octave input. This filter will track, you should count on it for about 5 octaves, which comes in handy because it is trimmed so that when the bandpass output is patched into the AGC and Q is set to 12 o'clock, you will get a plus minus 2.5 volt sine wave in quadrature out of the top 4 outputs, which will be, it's a pretty high quality quadrature sine oscillator that you can use for CV duties, or you could even use it for frequency shifting, all kinds of stuff. You then have a standard input with a manual gain knob, a trigger input, which is your trig in for pinging the filter and exciting the filter. And then you have a limit input and an AGC input. These are two different approaches to the same concept, and that is to limit clipping and control the amplitude of the outputs when you are increasing the Q and you are increasing the amplitude of harmonics. The limit input is a non-reactive, more static way to compensate for that, and the best way to show it is to just patch some sounds. So let's first show the problem that we're trying to solve. So let's turn it in, let's put it into the standard input, audio gain all the way up, Q all the way up, and let's listen to the problem. So it really bounces around, it clips, the Q is very high, and it's clipping out the core of the filter. So that's a problem when you don't want that. And the first way to fix it is with the limit input. Now the limit input works by, as you turn up the Q, whatever's going into limit is turned down. So you'll hear when I sweep this with Q at minimum, it's basically a flat filter. It's a flat filter, the same as it ever was. As I turn this up though, I've lost a lot of the original signal, the original oscillator sound, but I also don't have any clipping, and it works kind of like a magnifying glass. You hear every harmonic jump out, and then it drops out. So that's the limit input. AGC is a little bit different. It's a automatic gain compensating input, and it is reactive and less static than the limit input. And the way it works is kind of like a compressor, where it looks at the output of the filter, and if the output is too high, it turns down the input and will kind of duck the signal around harmonics. So similar, when Q is down, it's basically a flat filter, but as I turn this up, you'll hear the signal kind of get ducked around those harmonics. So with the AGC, you lose less of your original signal, but because it's a compressor is what does the effect, there's a time constant involved, and sometimes you get some beating effects and some things that are unpleasant, or sometimes that'll be what you're looking for, and you will like it. So the different inputs will be more appropriate depending on what you're doing. The trigger input is also done a little bit differently, and the best way to show it is to start by showing what it's good at, one of the things that it allows you to do. So I'm going to just plug this in, and it's a format patch. So what makes that patch work is really consistent pings and really consistent excitation of the filter. So to demonstrate the difference, we're first going to input a little pulse wave instead of this saw. And we will again put it into the standard input so that we can listen to the problem that we're trying to solve. So as I sweep this, so again, clipping, amplitude all over the place, hard to manage, all things that I wanted to avoid. So same signal, let's put that into trigger and let's see what happens. So this time, the amplitude, like the maximum amplitude that anything reached, stayed rock solid across the top. And the way that works is this filter actually has a sync input. So when a trigger comes in, first the filter is reset or synced to 0, the same as a VCO with a sync input would be, and then it's triggered or pinged. And what that gives you is really consistent pings and really easy to manage response of the filter when you're using that trig input. And at lower frequencies, that trig circuit also automatically compensates for the frequency of the filter to make sure that the filter is completely rung or excited by whatever signal. So now let's swap that pulse train that I've got on the screen here to a very low frequency, and we'll zoom out to several seconds. So we can see every couple seconds I'm getting a ping in. And if I put this into low frequency mode, I'm getting a nice pseudo-sinusoidal kind of envelope. I could play with the settings, get it a little bit closer, and you get kind of a smooth envelope in quadrature when you're using it for sub-audio CV generation. Now, without changing anything, I can put it into audio mode, and it will change that long trigger into a short trigger, which is what I need for audio range. So the triggering circuit will take care of adjusting things for jumping from sub-audio to audio use, and it will automatically adjust things. You don't have to worry about it, you just focus on making music. So hopefully over the next couple weeks I'll get a chance to show more context for some of these ideas in more musical context of why I worked on them. But for now, that is an overview of how this thing works. Thanks for watching.